Here's our next problem. Find two values on the interval 0 to 2 pi where the slope of the tangent to the graph of f of x equals cosine 2x is equal to the square root of 3. All right, let's do this problem. Now, this one is just a little harder. I'm going to have to introduce a new, it's not really that difficult, but I'm going to have to introduce a new concept to you. I'm not sure that we have done cosine. I guess I don't know if we've done cosine where there's a coefficient on x yet. All right, but that's okay. It won't be that hard for me to teach that to you. All right, so if we want to know about the slope of the tangent line, first thing we got to do is find the derivative. F prime, so actually let me write f of x down. So f of x equals cosine 2x. So this is what we're going to have to do here is use what's called a chain rule. So you're going to get a little introduction to it, and then you're going to learn about the chain rule. So it doesn't really matter what that we're taking the cosine of. It's going to be the derivative of, I like to call it cosine blop, because it doesn't matter what the blop is. All right, the blop is going to hang around anyway. But then once we're done, if that blop doesn't have a derivative of 1, we're going to have to take the derivative of the blop. And we will do this in much more detail in actually the next series of lessons is going to be the chain rule. But so here's your little introduction to the chain rule. All right, so f prime of x, the derivative of cosine blop is going to be negative sine blop. And the derivative of 2x is just 2. Now we do have to fill in the blop. We can't just leave it like that. It was 2x. So now we're going to write this a little nicer. So f prime of x equals negative 2 sine. We should move that in front. It's just a coefficient on the whole thing. So negative 2 sine 2x. All right, so this was step 1, and that was find the derivative. Step 2, we want to know where the derivative is equal to the square root of 3. So we're just going to set the derivative equal to the square root of 3 and solve. So we have the square root of 3 equals negative 2 sine 2x. All right, so the first thing we need to do is we do need to isolate the sine expression. So we're going to divide both sides by negative 2. Right, so that gives us the square root, negative, I'm going to put the negative up here, negative square root of 3 divided by 2 equals sine 2x. Now we need to isolate the 2x. And to isolate the 2x, we're going to use arcsine, because that is the inverse of sine. And we've got to take the arcsine of both sides. So we've got arcsine of negative square root of 3 over 2 equals arcsine of sine 2x. All right, so on this side we have arcsine of negative square root of 3 over 2. So arcsine and sine are inverses, so that isolates 2x. All right, so now we got to figure out what is arcsine of negative 3 square roots of 2. In other words, where is the graph of sine equal to negative 3 square roots of 2? And so I'll put that as C. Find arcsine negative square root of 3 over 2. All right, well, first of all, think about which kind of triangle it is. It is not, because if it has a nice number like that, it has to be one of two things, the 45, 45, 90 or the 30, 60, 90. It is not the 45, 45, 90, right, because that's 1, 1, square root of 2. The 30, 60, 90 is the short leg is 1, the long leg is the square root of 3, and the hypotenuse is 2. Right? And so in this case, remember sine uses opposite over hypotenuse. So the opposite sign is going to have to be the square root of 3. And actually, well, we'll talk about the sign for a moment. The opposite side will have to be the square root of 3, and the hypotenuse, well, of course, will be 2. But notice it's negative. And so where is arc sine negative? Where's sine negative? Sine is negative. Actually, let me move this up a little bit. So sine is negative here in the third and fourth quadrants. That's where sine is negative, where y is negative. All right, so now let's draw our reference triangle. All right, so this has got to be the negative square root of 3. The angle is always up against the origin. So negative square root of 3 is the opposite side. Hypotenuse is 2 is the hypotenuse. And it could also be over here. It's got two places. All right, so now we just have to figure out what that angle is in radians. Now, you might be thinking, if you don't remember, I'm going to refresh your memory. All right, so the angle that's opposite the square root of 3, that's the 60-degree angle. We don't really deal with degrees in advanced math. We deal with radians. So if I were to divide that, if I were to multiply that by pi over 180, I would have pi thirds. So that's pi thirds radians. So this is pi thirds. So this angle here, we know this much is pi, and then we're going to add pi thirds to it. So one place where sine is negative square root of 3 over 2 would be 4 pi thirds. Right, that's one of our solutions. I'll put it here too. 4 pi thirds. And now here, actually let me write something different. Here we're going all the way around, and the only thing that's left is pi thirds. We know this much is 2 pi. If we take 2 pi and subtract pi thirds, right, that would be 6 pi thirds minus pi thirds. That's going to be 5 pi thirds. So we had two places. We had here for pi plus pi thirds, which gave us 4 pi thirds. And then we had the other angle, which is 5 pi thirds. So now we're just going to set up our two equations and solve for x. So we have 4 pi thirds equals 2x, and we have 5 pi thirds equals 2x. And now our last step is to solve for x. And that's really easy, because you just got to divide both sides by 2. I'm kind of running out of space here. Let me just, there. No, I really didn't want it to do that. I really just wanted it to make it a little smaller. I still wanted the problem up. All right, that's close enough. So we're going to divide both sides by 2. So now over here, x is going to be, so if we're dividing by 2, it's going to be, I'll even write it in as 1/2, just to make sure I don't. Right, and the 2's would cancel, and so half of 4 pi thirds is 2 pi thirds. That's one place. And then the other place is, we're going to, again, multiply by 1/2. Nothing's going to cancel here, so this will be 5 pi 6. All right, and that's the two places. So we'll answer our question there. Let me actually just scroll up and make sure we didn't miss anything else for our question. So it just asks, find the two values on the interval where the slope of the tangent to the graph is f of x equals cosine 2x is equal to square root of 3. All right, I'm not going to find the y value. I think we're good enough with just the x values. But let's answer the question. All right, so the tangent line to f of x equals cosine 2x has a slope of square root of 3 at x equals 2 pi thirds. Because remember, the x values on the graph of sine and cosine are radians, and 5 pi, and x equals 5 pi 6. All right? So this one was a little bit tricky, but we solved it. All right? And if you have any questions, just let me know.